Let's use z-scores to find probability. Part 1. We're going to jump right into it. The average adult male is approximately 70 inches in height and a standard deviation of 5 inches. The actor Danny DeVito, I love me some Danny DeVito, he is hilarious. He's 5 feet tall. What is the z-score for Danny DeVito's height? Okay, let's refresh. A z-score is found by taking the value minus the mean divided by the standard deviation. Now, with that being said, all three of those things need to be in the same units. So we have 70 inches for the mean. We have a standard deviation of 5 inches. So the standard deviation is in inches, but Danny is in 5 feet. So we need to use our knowledge of 5 feet. Well, 1 foot is the same as 12 inches. So if I multiply across, 5 feet is the same as 60 inches. So that means now we have everything in inches. So now I can throw it in and say, all right, z-score is the value, which is Danny DeVito. So 60 minus the mean, which is 70, divided by the standard deviation of 5. If you put this all in your calculator at one point, make sure you put parentheses around your numerator because we want to, order of operations, you do your numerator first. So negative 10 divided by 5 gives me a z-score of negative 2 for our friend Danny DeVito. What proportion of the population is shorter than Danny DeVito? Y'all, I'm a big fan of drawing this out, right? So if we're talking normal distribution, we know with z-scores, the mean has a z-score of 0. So here's negative 1, here's negative 2. So here is our Danny DeVito at negative 2. If we want shorter than that, we are looking at the area to the left. Now, I like to draw this out because I am a visual learner. We know that when we use our table, we've got the z and we've got the probability. So I find my z-score of negative 2, and that given probability is the area to the left of that z-score. So we would have 0.0228, which is roughly 2.28%. Using that value, 2.28% of men are shorter than Danny DeVito, determine how many men out of 100,000 would you expect to be as short or shorter than Danny DeVito. So if we would say 2.28% of 100,000 men would be as short or shorter, how do we do that? Well, we would change this percent back to a decimal, so 0.0228. Of means to multiply, and we would multiply by 100,000. So 0.0228 times 100,000 gives me 2,280 men. So out of 100,000, 2,280 men would be as short or shorter than Danny DeVito. What's the probability a man is taller than Danny DeVito? Well, if we draw this and say, okay, here's Danny DeVito at negative 2 z-score, and this over here is 2.28%, then everybody on this side, it's everybody else, right? So we would take 100% minus 2.28%, which gives me 97.72%. You can also do that as decimals, 0.0228. Then on the other side, it's 1 minus 0.0228, which would give us 0.9772. Either way, same thing. All right, let's move on to our next example. Each month, an American household generates an average of 28 pounds of plastic for garbage or recycling. Assume the standard deviation is 2 pounds. What is the z-score for a household that generates 25 pounds per month? All right, so what do we know? Well, we're trying to find a z-score. So we know the z equals the value minus the mean over the standard deviation. In symbols, x minus mu over sigma. Great. What do we have? We have a value. Value is what we're looking for. So the x is 25. The mean is 28. And the standard deviation is 2. So let's substitute those in. Z equals 25 minus 28 all over 2. That gives me a negative 3 over 2 or a negative 1.5. So if I'm drawing my normal distribution curve, again, remember zero's in the middle. So negative, and we'd have negative 1, negative 2. So negative 1.5 is somewhere between those. So what proportion of households would generate less than 25 pounds? So less than 25 pounds, remember that 25 has a z-score of negative 1.5. So that's here. Less than that means shaded to the left. We go to our table. We look at negative 1.5, which gives us a probability, area to the left, 0.0668. As a percent, that'd be 6.68% of households would generate less than 25 pounds. What about more than 25 pounds? Well, graphically, again, we have 0. So here's negative 1.5. We know that the area to the left is 0.0668. So that means the area to the right of this would be 1 minus 0.0668, which gives me 0.9332, or 93.32%. So it depends if you want to talk about probability as a decimal or as a percent. Mathematically, they're equivalent, so it really doesn't matter. And I believe that's it.